circuits that are called sequential circuits. So we were actually dealing with the combinational circuits in which the output changes immediately when you change the input. So the outputs are not dependent upon, you are not actually checking the output at any instant of time or during a time duration. As soon as there is a change at the input, there are changes at the output. So these type of circuits, they are basically where any instant change will cause a change in the output. There is another type of networks which are called sequential circuits, in which your output is not only dependent upon the present inputs but also on the past state of the output. That means your input goes as a, the output of this goes as a input to a memory state, a memory, and then it is, that means your current output depends upon the inputs as well as the past state of the output. So that is what is a sequential circuit. Now in a sequential circuit, what is a memory? What is the basic element of a memory? So the basic element, memory element is flip flop. That means it stores two data. It's a bistable element. It's a bistable element and it stores two states. That is 1 and 0. So we'll talk about this basic flip-flop, which is a memory element which stores the data. Since it's a binary system, it stores 1 or it stores 0. So the basic memory element we start with is, suppose we have this. It's a bistable element. Now there are two NOT gates which are connected in such a way that the output of one is given as an input to the other NOT gate and the output of that is given as an input to the first one. So if you see here, if x is 0, then x bar will be 1, that is q is equal to 1, equal to y. And if y is equal to 1, then y bar is equal to 0, equal to q bar, equal to x. And if you take the other way around, if x equal to 1, then x bar will be equal to 0, equal to y, and y bar will be equal to 1, equal to x. So you can say that x bar is equal to y and y bar is equal to x. That means the two outputs x bar and y bar, they are complement of each other. So we just name them by q and q bar. So in this, whenever we say the two outputs are complementary, so we call this output as a normal output and we call this as the complementary output. Now in this you can see that this particular base stable element, it has two stable states. One is 1, another is 0. So when Q is equal to 1, then we say it is in state this, normal state or set state. And when Q is equal to 0, we say it is in reset state. So this is how we are going to talk about. It's about these bistable elements, and the basic element is a flip-flop. Now we start with a latch. Latch is one memory element whose output is not time dependent. You do not have, it is not time dependent. So we have two types of latches, SR latch and S bar R bar latch. So if we take an SR latch, they are made using this. Using a NOR gate. This is a SR latch. You can see the output is basically not time dependent. There is no time period, there is no control signal, there is no enable signal. It is totally dependent upon the input signals. And so this is the basic memory element which is being used everywhere. It is called latch. There is no control of the input. There is no control signal, there is no enable signal, there is no clock, there is no time period. So if you write a table for this truth table, this is a truth table. This is actually next state output, next state output. So it is just giving us Q and Q bar. You can simply draw this as a, if you don't want this, you can simply draw it like this also. It's an OR gate followed by a NOT gate, again an OR gate followed by a NOT gate. The symbol for this will be like this. This is the symbol, logic symbol for a SR latch. This is one OR. So these are the logic symbols for. So what will be the truth table for this latch? What it is showing? What is this? So if we have to, now we know that if S and R for a NOR gate, what is the truth table? If A and B are the inputs of a NOR gate, what is F NOR? If both are 0, it is going to be 1. If single 1, there is single 1, any of the inputs are 1, the output is 0. So this says that if the inputs are, if any of the inputs of a SR, SNR of a NOR latch, they are 1, then the output goes to 0. 1 rule. So if both the inputs are 0 and 0, this is 0, this is 0, that means your output now is dependent upon the second input. Suppose this is 0, this is 1. So this is 1, this input is 0, this input is 0. So this is 1, this is 0. 1 0 will give you NOR. 1 0 will give you 0. 0 0 will give you 1. The output remains unchanged. Next output will be 0, next output will be 1. The output remains unchanged. This is one thing. Second thing is both are 0 0. The output, this is 1, this is 0. ये भी हो सकता है when you switch on your SR IC, a latch IC, हो सकता है out there is it's a memory element. That means when you switch it on, there will be some data. ठीक है? So if this is 1, this is 0. Since they are complementary, will be complement of each other. So it may happen that this is 1, this is 0. So if this is 1, 1 0 will give you 0. 0 0 will give you 1. So the output remains unchanged. So it says that when both the inputs of a NOR latch they are 0, the output remains unchanged. No change. If it is 0 0, Q is 0, Q bar is 1, it remains the same. If Q is 1, Q bar is 0, then also it remains the same. Then we come to the next state when S is 0 and R is 1. When S is 0 and R is 1. When S is 0 and R is 1, and this is 0, so 0 1 will give you 1 0. 0 0 will give you 0 1. 1 1 will give you 1 0. When S is 0 and R is 1, then the output Q will be 1 and Q bar will be 0. That state when Q is 1, in the previous one we said that when your normal output is 1, that state is called set state. Set state. We can see the other way also. S is 0, Q is 1, Q bar is 0. 0 0 will give you OR 0 1. 1 1 will give you 1 0. That means again the output is whether the previous state Q is 1 or 0. If your input S changes to 0 and R changes to 1, the output, the normal output changes to 1. That state is called set state. What is the next? S is 1 and R is 0. S is 1 and R is 0. S is 1, R is 0. When S is 1, this is 1, output is 0, irrespective of anything. कुछ नहीं होता. जैसी एक input 1 होगी, Q 0 हो जाएगा. When this is 0, 0 0 will be 1. So output, अगर Q 0 है, previous output, and अगर S को 1 कर दिया, तो output Q remains 0. If previous output is 1, 1 0 will give you 0, 0 1 will give you 0, 0 0 will give you 1. So final output will be this one. So if S is high, R is 0, the output is 0 irrespective of the input. So we say it is called a reset state. And when both the inputs are 1 1, then Q and Q bar will be 0 0, and this state is called forbidden state. So this is a forbidden state which we don't want, because we want Q and Q bar to be complement of each other, normal. So it's a forbidden state where both are same. It is unpredictable, forbidden, not allowed, anything you can call it. So this state you can see in a latch, this is a not allowed state. We are just only allowed to use 3 states, 3 set of inputs. Either S and R should be 0 0, or it should be zero 1 or 1 0 or 1. So this is one type of, you can say, latch, where we are using a NOR gates. Another type of latch we have is a NAND latch. This is a NAND latch. What we do is we'll make a NAND latch here. We'll have here its truth table, next state outputs, and what is the truth table of this? You can also redraw it as a AND followed by a NOT gate. So its truth table is like this. Its symbol. Or again, no problem when both are 0 0. Now in a NAND latch, if you look at a NAND latch, sorry, this is R, this is S. So when set is high, output is set. When R, so it is called also called active high latch. SR latch with NOR gates is also called active high latch. So in this NAND latch, what is a NAND? If both are 0, output is 1. If both, this is 1, and if both are 1, 1 of NAND will give you. So if any of the inputs is 0, the output is going to be 1 for a NAND. So if they are both 0 0 S bar and R bar, then both the outputs are going to be 1 1. So this is basically a state which is not recommended. in which both the outputs, normal output and complementary output, goes high. So this is a forbidden state again. So in this, for 0, 0, it's a forbidden state. Then S bar is 0, R bar is 1. When S bar is 0, if any of the input is 0, this is going to be 1. If this is 1, S bar is 0, R bar is 1. This is going to be 1, so 1, 1 will give you 0. 0, 0 will give you 1. So at the end it will settle down to 1 and 0. Similarly, when S bar is 1, R bar is 0. This is 0. This 0 means NAND gate output is going to be 1. It will not wait for the second input. क्योंकि NAND जैसे ही NAND की एक input 0 होती है, output becomes high irrespective of the second input. So this is 0, so this becomes high irrespective of the second input. If it is high, 1, 1 will give you 0, 0, 0. So the output becomes stable. Q is 0 and Q bar is high. And finally, when both the inputs are 1, 1, then only your NAND gate will respond to both the inputs. These are both 1, 1. 1, 1 means there should be something here and there should be something here, just to get the output. So if this is 0, 0, 1 will give you 1, 1, 1 will give you 0. So output remains unchanged. So this is previous state of QT and this is previous state of QT bar. Timing, it just tells you the timing. जो पुरानी time पे value थी, नई value भी, it will be same as the previous value. So these were the latches where the output changes instantaneously, immediately when the input changes. It does not wait for any control signal, any enable signal. It's just free of them. No clock, no enable, no control signal. So these are the two types of latches. This is called active low latch. A NAND latch is called active low latch because when your reset is active low, set is active low, your output is high. When your reset is active low, your output is 0. So that is why it is called active low latch. In this case, it is called active high latch because when your set input is active high, output is 1. When it is active high, output is 0. These are two basic building blocks in our sequential circuit which stores the 1 bit of data. And they are independent of any enable circuit, any control signal, any clock signal. Then we have gated SR latch. A gated SR latch. Now you can see that the two latches we have drawn, they have 4 states, and out of 4 states, 1 state is forbidden. So we should look for certain latches in which we can remove this forbidden state. So another is a gated latch where you will have a control signal, gated SR latch. It's like this. The basic element is a latch. It's a NAND latch. There is a control signal. I just number the gates 1, 2, 3, 4. This is a basic latch. What is the next state of our output? when your inputs are 0, 0. And there is a control also, so I should have a control also. If control is 0, if the control is 0, what happens? This is 0. These two outputs will be 1, 1, irrespective of S and R. So that means they don't care. And when they are 1, 1, what is Q and Q bar? It is same as the previous value. No change or unchanged. So when your control signal is 0, it is not affecting the output at all. When your control signal once becomes 1, then only it will respond to your direct inputs. So these S and R actually, they are called asynchronous or direct inputs. So we have 1, when this becomes 1, then this 1 and 2 gate, NAND gate 1, NAND gate 2 will respond to S and R inputs. So when this is 1, these both are 0, 0, these two inputs will become 1, 1 and outputs of NAND gate, and this will remain as it is. Then when control is 1, S is 0 and R is 1. This is 0, 0, 1 will give you 1. This is 1, this is 1, this will give you 0. This is 0. If this is one of the inputs of a NAND gate is 0, 0 will give you 1. 1, 1 will give you 0. So this is Q goes to 0 and Q bar goes to 1. And when your normal output is 0 and the other one is 1, that means this is a set state. So here you can say it's a latch which is being controlled by the control signal or enable signal, and when that signal is active, then only it will show the output. Otherwise its output remains unchanged. So this is 1. If it is the other way around, R is 0 and S is 1. R is 0, let's not have these intermediate states. This is 0, so this should be 1. These are 1, 1, this should be 0. Fine. It's clear. NAND gate का मैंने एक function बताया. If any of the inputs of a NAND gate is 0, output is 1, irrespective of the second input. This is 0, that means it should be 1. 0, हो गया तो 1 हो गया. 1, 1 will give you. Q is 1, R is 0. It's a reset. And when all are 1, this is 1, this is 1. So when all are 1, they are both 0. NAND gate output of gate 1 and output of gate 2 will be 0. And when both are 0, 0, they are in. This is a forbidden state. The problem with this is we do have a control, but one of the state is not usable. So what we did was we looked for another latch. It is called a gated latch, where this forbidden state is eliminated. Let's draw the symbol of this. Gated SR latch. We have S, we have R, we have control signal C, we have Q, and we have Q bar. Or the other way around, you can have a gated D latch where there will be a one, two, three. So this is through an inverter fed through this. That means both the inputs will be either 1 0 or 0 1. This is 2. This output is fed as an input to this one, and this input and here we have a control signal. So this is a gated D latch where we are able to remove the problem of forbidden state. So here we have a gated D latch, we have a control signal, we have a gated D latch, we have output Q, next state output Q, and its next state output Q bar. So if we draw the gated symbol of a gated D latch, it is D and we have a control signal. So if control is 0, irrespective of the value of D, the output is D is, if control is 0, output will be control is 0. So this will be 1 1, and if this is 1 1 according to the NAND latch, the outputs are same as the previous ones. No change state. So whenever we don't want to change the state of the flip-flop, you can make use of this particular position. When control goes 1, either D will be 0 or D will be 1. When control goes 1, so D is 0, so this will be 1. This is 0. So 0 1 will give you 1 and 1 1 will give you 0. So this is 0. If one of the inputs of a NAND gate is 0, then what will happen? This will go to high. And this is 1 1, it will go to. So it will stable down and the output will show Q to be 0 and Q bar to be. Similarly, the other way around, if D is 1, so this will be 0, D is 1. When it is 1 1, this output will be 0. When it is 1 0, the output will be. Again, when one of the inputs of a NAND gate is 0, the output is going to be 1. This 1 1 will give you output to be. So output changes. So we just have two states. The forbidden state has been removed and we are able to get two states for the control 1 and third state will be for control 0. So these are the gated latches. Latch means the output is just not dependent upon any instant of time. We are getting the output because whenever there is a change in the input, we are getting an output. So whenever you have a IC of a latch, NAND latch or a NOR latch, and you switch it on, it will always store some value. It may be 0, it may be 1. That is what is there. So every latch stores just a 1 bit. If you need more bits to be stored, you require that many latches. This was all about your latch. You have just two basic elements. One is a NAND latch, another is a NOR latch. They are bistable elements because they are storing 0 and 1. There is no other state. It's a bistable circuit. So basic circuit we did it, we draw it, and then after that we had a controlled latches which are controlled using a control signal or enable signal. And just to remove that forbidden state, we have a gated D latch. It is also called transparent latch because It's transparent. Whatever is at the input will be at the output. If input is D, input D is 0, output is 0. So it's transparent. When input D is 1, output is 1. So whenever a control signal is high or control is active, your output is same as the input. So it is also called a transparent lamp. It just stores the data and gives you the same data. So in the next class, we will be talking about the flip-flops.